Okay, so in number 4 here, they've got this spring scale that's holding up the mass. Now, spring scale has the word spring in it, but all we need to really know about it is that it's a device that measures force. So a force is being applied upward to this mass, and how much force that is measured on the spring scale. So I'm just going to call it F. So for part A, I'm going to draw the free body diagram of the objects in this position. So see if you can do it on your own. Push pause. I have mg pointing down and F pointing up. And that's all there is. So then I can write the equation of that, F minus mg, and that's going to be equal to 0 because it's not moving. So in this part of the problem, they gave you the mass. Of course, you know what gravity is, and they ask you to calculate the force, the reading on the spring scale. So that should be pretty easy. Then, in part B, they lower the mass so that it's now sitting on top of the spring, and the spring is compressed down a little bit. The spring scale is still here, and it's still measuring force. So now the reason why the mass isn't moving is partly because the spring is pushing up on it, and partly because the spring scale is pushing up on it. So when I draw the free body diagram for this, part B, I do mg pointing down, the spring scale pushing up, I'm still going to call that F, even though it's going to be a different number now, and then the spring pushing up, and I'm going to call that Kx, because it's a spring, and so its force is equal to Kx. Now I'm going to make the equation that goes with that diagram. I have F and Kx. They're both going up, so they're both positive. I have mg. It's going down, so it's negative. And those are going to add up to 0 because it's still not moving. So in this part of the problem, they gave you F. You know m from before. They gave you x, and they're asking you to calculate k. Well, if you know f and m and g and x, you should be able to calculate k from this equation. Then the last part, they're going to put the mass entirely sitting on the spring, so it's squished way down, and now the spring scale is not holding anything anymore, so it might be kind of flopping over sideways because it's not holding anything anymore. So for this part, we draw a new free body diagram. We have mg pointing down. We have kx from the spring on the bottom pointing up, but we have no force from the spring scale anymore because it's not helping. So when we write the equation, we just have kx minus mg, and that's equal to 0. We could have also gotten this equation by going back to part B and looking at this equation and making the force equal to 0. So in this part, we have k from part B. We know that mass, that was given at the beginning of the problem, and they're going to ask you to calculate x. And so you should be able to do that right from this equation here.